Guys sit around here.
So here we are, live on YouTube. We'll be starting London DevOps very, very shortly.
We'll unplug it. It's different when you're doing it to other people in your bedroom.
Yeah. Yeah. You okay there?
Yep, we're live on the internet. Hello. Right, good.
What time was the first presentation supposed to start?
Start there from I think I put it down to 7.
7?
Or maybe the intro at 6:45. So
You had 7 and 7:15.
7 and 7:15. Thank you. That's something the program.
So start at 7.
Starting at 7. Is that all right?
Are we finished at 8:30, right?
I was so ready to get a burger when I got the tube. And a burger? No, coming up here, I'm starving. Should I stop and get a burger? Oh, I see, yeah. Yeah, I knew the good pizza, but I also was quite hungry before I left. I knew I'd be running around, so I grabbed something at Leon. All right, so.
Yeah, so the lady said I could probably sit down, but I'm going to stand up and hold it. But really, and it's not going to come back.
Yes, of course, you're the cable something.
Yeah.
Okay.
I mean, I could put it in the street, but that's almost the yeah, so every time I change companies, as long as I get a Mac, just keep the case. So the case actually comes off. So saves you having to. No. Well, I shouldn't. More than half of this is. I know HTML.
It's 995.
Yeah, exactly.
I reckon I have it a lifetime. have to be now, but
Well, there's no point, right? Yeah. This is from, yeah, I joined BBC just before. Exactly. And I did ask her. I said, it's good. Lot going on, a lot of stuff going around. Yeah, it's difficult, but BBC's one tough to keep up.
So is that not enough work to do?
No, it's not. Main thing is it's a work really interesting stuff. Yeah, it's permanent. Exactly, that's the kind of thing. So as soon as juniors become midway,
Yeah, that's frustrating. You can't find a career level.
I mean, some of the grades they could back up. It's just getting to those grades like yeah. Yeah, they do have money. It's fixed, right? Fixed some every year. So they just
It's it goes so fast. It goes so easily. So that's what is so far more our experience. So it's what's like
that was massive CDM.
is that through
Yeah, one of them.
so it's check by screen. Oh, look at that. Right there. Yeah, so I was concerned about the range of some of their speaking in big companies. So Mark, it's very all sorts of throw out long range microphone, like roads. Here's a shame, yeah. Smoothly into yeah, so it's usually here doing all that sort of thing. Yeah, so bring up my old camcorder, which I last used to run with DevOps. Probably peaked for 4 years. Still works, still seems to do the job. SD card, it's 2 hours 30. It should be good. Right. Yeah, it's good. It's good. This one. Yes.
I find it spots, yeah. But yeah, it never occurred to me to jump into class. Never choice for me. Done a couple of always use my notes. Yeah, no, we're gonna Yeah, no, for a minute, it's so funny. Yeah,
I'll get on here and just say, come over, we'll start in 5 minutes.
Yeah, I think it's, yeah, a couple of minutes. 6 minutes.
Hello. Hello. Hello, R3. Can you hear me? We're going to get started in a couple of minutes. You want to come over and sit down? We're going to get started in a couple of minutes. Microphone's going to be fine once everyone's quiet.
No, I'm just going to put the volume up just to make sure it's up.
All right, cool.
No, it's up.
Live stream working? Yeah, cool. It's on recording. Yeah. Yeah, yeah, it's keeping an eye on that. Fabulous. All right. Hey, right. Let's go. Right. Hello, everybody. Hello. Welcome to London DevOps. We're back in someone's office for the first time in a year and a half. Yes. Thank you for all coming. Who here is working for R3? Andrew, yeah. So now a few other people here. Cool.
Only 2 or 3 of us.
Only 2 or 3 of you. Excellent. Thank you for coming. Thank you for hosting us. I'll give you a moment to say something about R3 in a second. So who's here at London DevOps for the first time? Quite a few people. Right, where's the echo coming from? It's my pocket. That's what it is. It's my pocket. So that means that the live stream is working. That's excellent. Sorry. So yeah, first time. Sorry, I didn't see. Who's here for the first time? Excellent. Who's been here for a few times? We're not here, but London DevOps a few times. Excellent, good. I'm always quite glad that we get lots of new people at each meetup, and also that it's not just new people, because it then proves that people come and don't want to never come again. So that's really, really good. So yeah, we're here at R3. Thanks very much to our hosts, Sonal and Andrew. So Andrew's going to say a couple of words about R3 if you want to, and why you're hosting us tonight.
Good evening, welcome, thank you for coming. So R3, who's heard of R3? Only a few. So R3 is very well known in the fintech world because it's the largest business enterprise permissioned blockchain network. We work with large corporates and major banks for those kind of things. We're moving into new areas now. So, of course, like everyone who does presentations and invites meetups, we're hiring. Later or on our website. Welcome very much for coming. I hope you enjoy our humble abode. And you've got to put up with me talking later.
Oh. Thanks, Andrew. So, DevOps. Who here would say that they are a DevOps engineer or does DevOps? Yeah, reasonable amount of people. Cool. DevOps has been around for what, 11 years now, and we don't really know what it means yet. Still, various definitions going out there. This is one of my favourites from Ken at ThoughtWorks. Cultural, so a culture where people couldn't get together to do some cool stuff, basically. Maybe DevOps means that to you. That's from John Vincent. Getting involved in not just your own work, but the work that others do around you. So the people who are next to you, what are they doing? How can we help them? How can we help them? Then how can they help us to be successful? Because we're all trying to do the same thing, right? DevOps culture, maybe. Good book there by Mandy. Or maybe DevOps means that. Yeah. Who uses all those tools? Nobody. Yeah. Yeah. So maybe that's what DevOps means to you. I like the infinity loop. The infinity loop is a key thing for me personally. Take away what you want from what DevOps actually means. Is the point here over the last few slides. Is it cultural? Is it process? Is it tools? You decide. It's all of them, really, probably. So that's what DevOps is. London DevOps. So we've been going for. We've kind of missed our 7th anniversary. London DevOps has existed since 2014 when we had our first meetup over not very far away from here at Just Eat. So you've been going for a long time. This is meetup number 64, which I guess is a kind of round number, right?
Yeah, wonderful rehearsals and geeks in the room. So London DevOps is here. We're here to share. We're here. We're broadcasting on YouTube. We're recording. We've got 50 odd people here that we're talking to. It's about sharing. The two talks you're going to hear are about sharing knowledge. That's what it's here for. If you hear anything you hear that you want to repeat or go away and tell your colleagues or your dog or whatever tomorrow, it's fair game unless otherwise indicated. It's all about sharing, as indeed DevOps is. So yeah, meet new people, say hello to someone you don't recognise. I know you're probably introverted like me and it's a little bit scary, but it's fine, nobody bites. At least we haven't thrown anyone out for the code of conduct violation biting yet. Maybe it's the first time for that tonight, I don't know. Here's our YouTube channel. We're broadcasting live on the YouTube channel, as my phone very embarrassingly proved. So yes, this is the first meetup, first kind of real meetup that we're doing post-pandemic or towards the end of the pandemic or whatever stage you want to class as being in the pandemic, don't really know. So yeah, we're live on YouTube. We've got some people watching it, which is great. All the old videos are up there on YouTube as well, going back years and years and years. Brilliant corpus of knowledge there, if you want to go look them up. And the talks that we're doing tonight will be there. Actually, they'll probably be there straight away afterwards because the live stream's recorded. There's the code of conduct. Yeah, it doesn't mention biting. I don't know why I was thinking that. There we go. That's what it does mention. I'll just leave that up there. And I will say we have had to enforce it. I think just once or twice. Generally being an alcohol-related incident, which is no excuse. But that is the code of conduct. Please stick to it. And if you don't like it, yes, it's so. All right, so this is us. There's 4 of us organised this group. I've been doing it since 2014 or so. So Mark sadly can't be here. He's got a work obligation right now. Those are his contact details. He's been instrumental in the group. In fact, he was the guy who tapped me on the shoulder 7 years ago and said, "I've just picked up this group. Do you want to help me run it?" Yeah, cool. So that's the 2 of us. But we're ably helped by 2 other guys here. Sorry about all the white guys. We're trying to improve that. If anybody else wants to be an organiser who doesn't look like a white guy like this, please let us know. So yeah, 2 other organisers. We've got Jack from WeShape. Hello, Jack. Where are you? Done this somewhere? Hello. Hello. For you watching on the live stream, Jack says hello. And also Alex. Where are you, Alex?
I'm here. Hello.
Alex is right here. Cool. So yeah, 4 organisers. If you like what you see here tonight, if you want to do more of it, if you want to help us do more of it, either by providing sponsorship, venues, pizzas, talks are always welcome. If you're thinking, oh, I could do a talk a bit like this on a subject a bit like some of these that we see tonight, or even anything to do with DevOps, then hit us up. Hit us up. We'd love to hear from you. Talking of hearing from you. There's a hashtag, so if you see something interesting you want to talk about, let's get the discussion going on Twitter. Hashtag London DevOps. So on to sponsors. So yes, it's been a bit easier. Well, for all of us, the last year and a half has not been easy, but it's been a bit easier running events because we haven't had to worry about things like venues and pizzas and beers and logistics, all those sort of things. But we do need to do those things to do the events that we want to do. And going forward, when it's safe, hopefully it's safe now. It's a bit late right now. Going into 2022, we want to do more physical events. So yeah, we need sponsors. So Prism Digital have been with us from the very beginning. Alex, did you want to say anything about Prism?
Yeah, just it's great to be a sponsor. Oh, very cool. Thank you very much. Yeah, great to be a sponsor of the group. Great to have been involved with the group for so long. We are a DevOps and cloud talent partner. So if you're looking to hire DevOps engineers into your teams, I'd be very happy to talk to you. And if you're looking to work in the DevOps or cloud space, I'd be very happy to talk to you as well. So that's us. Thank you.
Thank you, Alex. So we're also supported by Adaptivist, mainly through them allowing me time off of my day job to go around doing this sort of thing. So Adaptivist are an Atlassian partner. I've actually partnered with a lot of other companies as well. People like GitLab, Sonatype, AHA, etc. Not the Norwegian rock band. Around basically digital transformation, helping people use tools better. Mostly Jira, and it's surprising company because there are lots of people who don't hate Jira. So if you also don't hate Jira, come on, work with me. Okay, everyone wants to fine. Weak shape. Next up, Jack, do you want to come say a bit about weak shape?
I bet I suppose everyone else has. So.
Come on, get yourself up here.
Sorry guys, no big pitch, just a quick hello from us. So we're a technology consultancy focusing on DevOps and cloud native space. So we work on advisory, project implementation, got a product arm coming out soon. So yeah, if you're looking for a contract in DevOps or a permanent position, come grab myself or some of the team. Yeah, great to be here.
Good stuff, thanks, Jack. We're also sponsored by Tyke. So Tyke provide API services. I don't think anyone from Tyke's here tonight.
Couldn't make it tonight.
Couldn't make it tonight.
They want to come to the next one.
Yeah, Tyke will be the next one. So we'll get a demo from Tyke next time if nothing else. So thank you to Tyke. So yeah, go and look up their services at tyke.io. And finally, O'Reilly sponsor us by sending us some books, but they haven't sent us any for a long time, so I'm going to skip over that book. No, seriously, it's good. We do some giveaways around books and things. I'm sure O'Reilly needs no introduction to anybody else. So tonight we've got two talks coming up. So first of all, we're going to hear from Edge. Did I say that right?
Yeah, that's fine.
I should have written that down, sorry. He's going to talk about football. Yes, who's a football fan? Yay, cool. Apparently there's not actually all that much football in the talk, so boo, yay. His stuff. No, seriously, scalability and fault isolation around football matches is something that's very tangible for anyone who's got a passing interest in sport or events or anything. So that's an excellent talk. And then after that, R3's very own Andrew is going to talk about supply chain integrity. Okay, we might have a panel session if we have time. That's pretty much it from me. I'll shut up and get off the stage and let some people who really know what they're talking about take over the time next. Give us some feedback. There's the meetup group link. There's the hashtag. This one apparently is some technology called email, which I think is what people used to use before everyone used Slack. So if you want to send us an email, it's org squiggly thing londondevops.co.uk. That's it. Right. Okay. So just have a minute or so while we get Ed set up, and we'll move on with that talk. Thanks, everyone. You got enough battery?
Yes. That's always good.
Okay. Hang on. What have we got? USB-C. Right. I've been emergency fix you if you want to.
See that? Oh, I did put it on this side.
Yeah, I think let's try this side. Hold on a second, I might need to move to the table.
Okay. Well, definitely works.
Hey, it's me. I've got 1,000.
There you go. I pressed something. So.
I don't know what happened there.
There you go.
There we go.
Try that again while it's up. Excellent.
You happy with that?
Yeah, I'm happy with that.
Excellent. Over to you then, Ed.
Thank you very much. Hello, everyone. I'm Edge. Can everyone hear me? Yeah. Hi. Just to pre-warn you, I haven't practiced this for a long time. I've been doing it all on Zoom, funny enough, for the last 2 years. So all of my notes are here. Mark didn't tell me it was in person, so it's his fault. So apologies in advance. But this talk is about streaming Euro 2020 this summer. So we did it at record scale, and I'll dig into that a little bit. So just to kind of kick things off, we've got very, very professional agenda. So my name is Edge Barrett, or Edge, and I'm the engineering manager at BBC, working in a department called Media Services, which is a team of about 70 people, mix of engineers, product, BAs, SRE, all kinds of groups of people, and you know, about 40, 45 of them that report directly or indirectly to me. So gender-wise, oh, I've got a Twitter thing if everyone wants to follow this, watching that. The agenda is going to talk about summer 2021. How did we scale? But to do that properly, we need to go back to 2018 first to kind of go over why we did it in the first place. So we're going to kind of have a little bit of a segue into how files and media files at scale work. We're going to then discuss a little bit more drilling down into the architecture. And then hopefully things will start to make sense once I go through that. And then what is the BBC planning to do for the future? So give you some indicators and some ideas of stuff that we can publicly talk about, at least a little bit of. So yeah, we had a very busy summer. So we offered a rich selection of events. We had the Euros, obviously. We had Wimbledon and Tokyo Olympics, although that was kind of reduced for us this time. And it's, you know, an ever increasing portion of the audience for these events has been moving from traditional broadcast to online. For example, the final itself, we'll get to this a little bit, we set a new record with 7.1 million views streaming the match online. We also had a UHD beta for that. And the UHD beta, if you don't know, is Ultra HD, Ultra Definition, 4K televisions, all that good stuff. We had a beta of that, and we were hitting about 13 terabits a second across the internet network. AWS wasn't very happy with us that day, but it was an exciting time, and it really showed that UHD is probably one of the next stages we're going to look at next year. So how did we scale? So live streaming architecture is, you know, doing it reliably is hard, and we deliver this media, and, you know, all of this is near real time. So how do we do that and reach new heights? So we're just going to kind of start to dig into that. In order to answer that question, we're going to go back to 2018. So we went from a pull model to a push model. Thank you very much. That's what we did. No. Many streaming platforms, including iPlayer and all of the kind of client services that we provide this service to at the time in 2018, operates commonly known as a pull model. The player on your TV or phone or computer requests a media from a third party. This is usually a content distribution network or a CDN. This forwards on the request to the BBC routing and caching services, so which in turn sends on to something called a packager. So you can see this, there's a packager there, very, very simple diagram, but the complexity underneath I won't go into. The role of this last system was to transform the encoded media to wrap it into raw video and audio into a container, and then that's suitable for distribution to a variety of client devices. So that simple box there with the CDN, by the way, that's 5 caching layers, not just one service or one block of service that we use. Complexity of that was one of our driving reasons not to go and find another CDN provider, for example. So we really looked at how we could remove that complexity as part of that. So kind of just to finish on this diagram, you can view things as a funnel. Multiple layers of caching and routing are present all along the way to collapse millions of player requests that come through the client, which is iPlayer usually, but it can be news, it can be sport, and weather. And they every second, and they trickle down requests back to the origin media packager, which is basically pretty much on-prem. And each layer pulls the media from the next layer up, and all of this occurs while trying to keep close to live time as possible for the event that's happening at the time. So what happened? Something went wrong. So during 2018, England were playing Sweden, and our routing component had a major incident. So we had experienced, shall we say, a temporary wobble, which had a knock-on effect that caused the CDN, would you believe, to fail to put just one piece of file through that service that I showed on the diagram earlier, and that had a huge, unfortunately, knock-on effect. The CDN increased its request for the same file over and over again as part of its normal strategy, so making the problem worse. So eventually, the internal caching was disabled by the CDN, meaning that instead of collapsing the player requests, it started to forward on millions of them directly to our BBC packager, which is close to on-prem. It wasn't designed to serve several terabytes of video data every second, and was completely overwhelmed. So although we use more than one CDN, they're all connected to the same packager server at the base, so the funnel comes straight through, which led us to being unable to serve other CDNs, and a couple of minutes into extra time, all of our streams went down, and angry football fans everywhere were cursing the BBC across the country. Fortunately for us, the match result was all but confirmed. Unfortunately for Sweden, it was into the last few seconds, but we did take extreme notice of it. So we had several root cause analysis sessions. We had our DevOps teams look through all the login services, all the data that we could find, and we came up with root cause that allowed us to then proceed forward with a new architecture. So we moved forward with that. And then we started to plan for 2020. Well, we know what happened in 2020. We moved to 2021. We decided to re-architect the system. So by switching from a pull model to a push model. Yeah, simple as that, really. Obviously, the diagram gets rid of a few more blocks. The idea itself is really quite simple. Produce each piece of media and publish it to a dedicated live origin service per CDN, per content delivery network. From where the BBC stands, the CDN acts as a pure ingest point, has no visibility on any of our other services. And that's fundamentally one of the strengths, excuse me, of the change. In other words, we alleviate any risk of the CDNs overwhelming our systems. As more people view our streams, the load remains constant. We end up with much cleaner separation of concern, with the BBC accountable for producing the video and the CDNs accountable for distributing the videos, making it available for download at scale. So as a consequence, we have a much better understanding of CDNs. One of the biggest factors of this was we reduce our complexity of CDN usage, but also CDN technology also caught up with us. So we were able to store media at the storage edge of the services that they provide now. And that's a kind of common thing that's been happening in the last few years in that environment. So before I go on to the architecture itself, I thought it would be interesting to give you some information, data, numbers, and a quick segue into all the media files and segments and what it takes to deliver this. So we have something called adaptive bit streaming, sometimes shortened to ABR, and it's a dynamic way to compress video quality and audio, actually, so the files can be transmitted. Before they arrive at our packager, video and audio signals are encoded into a format appropriate for distribution to our audiences. The cloud-based encoder is also responsible for generating the ABR, the adaptive bitrate set of outputs. In other words, a range of pictures and sound quality to cater for different network speeds and device capabilities. The resulting encoded media is then sent to a packager. Its role is to prepare all of the files, and I'll touch on this in a minute, which will be requested by devices to play the streams. We kind of have two versions of those. The packager produces two types, one called HLS streams. In our case, this is kind of an encoded media package that's fragmented, generally speaking, for Apple devices and some older televisions. And what we use in the main, in the BBC, we also provide something called Dash, which is what you might more commonly know as MPEG-4. And for our terminology, we call it fragmented MPEG-4. If you want to know, the real thing is MPEG-4 part 1, 2. So go over those numbers on the slide. There's chunks of media files, about 3.84 seconds in length per file. 16 segments of those is about a minute, approximately. 937 of those files is about an hour. 22,000 is about 1 day. So the video quality of that I mentioned earlier, we produced that 8 times. So we have 8 profiles per file, whether it's Dash or HLS. So that's 16 times. And also, obviously, we provide the audio that goes with Dash in particular. Dash separates the audio and video. iPlayer will pick up the bit rate and adjust based on the various network containers. But that's not all. That's just 1 channel per day. So we do this for 40 other channels, which is a mixture of HD and SD. These run 24/7 and follow the broadcast channel. So if you have BBC One HD, 2, and so on, and various regional channels, means we need to probably generate approximately around 400,000 unique segments per hour for video, 225,000 unique segments per hour for audio, and yes, that's about 100 plus radio channels as well. This is again multiplied because we use it across 2 AWS regions for redundancy in the main. So huge numbers as we start to scale out. I don't want to look at how many terabytes of storage we have in S3, but you don't want to know. Moving on, so just kind of drilling down into how we kind of approach the new way to scale out in this way. Just kind of want to go quickly over this diagram. We'll dive into each box individually, but at a high level, the revised workflow is composed of 4 main components: the repackager, the distributor, the manifest generator, and the conductor. I won't mention this, but internally we have some crazy engineering names for these. I'm not very happy about them, but we are where we are. Come and talk to me off the record and I can tell you. The repackager itself, oh, something happened? Oh, we're back. Okay, so the repackager is part of something that the encoder sends. So the upstream encoder produces a version of video using, you might have heard the term H.264 standard with a AAC audio standard with it. As mentioned in the segue, both the video and the audio are wrapped in a transportation layer or a TS file. These are containers, and the encoder continues to send small container files, which have roughly about, as I mentioned earlier, 4 seconds of content each. The repackager component is an API internally, so it receives these chunks via HTTP put requests. Conveniently, their format is suitable for HLS directly, so we don't need to do much with them. The repackager just simply forwards them untouched to the next component in the workflow, which is the distributor. Unfortunately for Dash, we do have to do some work. So we get the data from the repackager, we parse the actual file, the container, and we extract the metadata from it, as an example on the screen. Using the information gathered by reading through the metadata, media data, we rewrap the picture and sound in an MP4 container with all the required metadata, and then send that forward. The generated MP4 is then sent alongside the TS file that I mentioned earlier to the CDN. The distributor component receives the MP4 and transport stream chunks sent by the repackager. This is all over HTTP, by the way, if you weren't sure about that. And in turn, publishes them to the CDN storage location so that our audiences can access them depending on the stream. Our audiences don't technically know where those files are yet, but I'll get onto that in a second. One file may be published to several CDN endpoints for additional redundancy. The distributor can essentially be viewed as one-to-many mapper, handling all the authentication and retry behavior when interacting with all the CDNs. Additionally, for every TS or transport stream chunk it receives, the distributor sends a request to the manifest generator, and I'll get onto that in a second. It triggers the generation of manifest corresponding to that file or chunk. So maybe you might be able to guess what this does. Manifest, if you're not aware, manifest generates a file called manifest. So it's a text document. It contains some textual information about that particular file. The primary goal is to guide the player or the client to download different media chunks within a given stream. When the player button is pressed, the player first downloads the manifest first, doesn't download the video. and using the information it contains, keeps on requesting small media files containing 4 seconds of content. So the manifest tells it where to go. If there's a failover of one CDN, it actually tells it to go to perhaps to another CDN. So all of that is in the manifest files. The downloaded files are rendered one after another, allowing the viewer to have continuous and seamless, from a viewer's perspective, playback experience. So HLS and Dash define different types of manifests, and the manifest generating component is responsible for creating these variants. Generating manifests are sent to the distributor component over HTTP to be published on the CDN alongside the media. So these files also go with almost the same timestamp as the video files and sit alongside them where the iPlayer or other clients can pick them up. The producer provides several REST API endpoints to configure behavior of other components in the workflow. So, for example, it's responsibility for driving the automatic scaling of the microservices behind all of these boxes, and where additional streams are started, adjusting the monitoring, keeping track of start and end time of live events, does certain filtering of encoding inputs. So if a lower level encoding is required, it will filter against those files, and a variety of other management tasks. You might know in the engineering world as perhaps an orchestration service. So that's another way to maybe one day we'll use Kubernetes for this. Finally, always good to show an AWS. This is a blurred AWS diagram to show it does exist. Lots of stuff going on in there, and hopefully you can roughly make out the blocks of information in relation to the discussion that I just talked about. So this is the obligatory diagram. This was driven by a cross-development effort, individuals, several teams, many departments, and the workflow has been successfully running in production now since February. We initially trialed it with BBC Two HD. Hopefully no one noticed this change, but it worked. It's continuously carries now over 40 streams, with additional event streams soon to be migrated. We do all of this with regard to process, tools, and people. All of this is in the DevOps manner. The teams and the groups of people responsible for this engineering look after in a DevOps process, right? We've got an SRE team that enables everyone else to build across these. We've got lots of metrics and lots of stuff that I haven't mentioned here. We have a TIG stack, we call it internally, but externally, you can think of it as Grafana. That provides us lots of data and inputs to further identify where we can improve some of these services and scale them a bit more. Just to kind of finish off on that, so I'm getting close. I've been quite quick, so apologies about that. What are we doing? So what are we paving way for the future? So even though the numbers here fit well within the realm of hyperscale, when it comes to data producer network, it's actually worth remembering still that online streaming is a small portion of the BBC's audience coverage. So, for example, compared to broadcast still has 10 times the number of viewers, so approximately 25 million in comparison, right? Linear broadcast TV still makes up the lion's share, probably be here for a good another 10, 15, 20 years. However, online consumption is steadily increasing year on year. Just to give you a bit more insight, our internet traffic and bit rates, for example, have been doubling approximately every 2 years. So in 2016, we were transmitting around 3 terabits a second. In 2018, 3 terabits in 2016. 2018 was 5, and now you can guess where we are now with what we're doing. Over a million new files are produced every hour, and billions of media chunks have successfully been uploaded to the CDNs that we've run storage since its inception. Across the summer events, sporting events, the system allowed us to reach a record 250 million plays on BBC iPlayer and Sport. So it's a huge number. And that's my last slide, and I do want to get in. BBC's always hiring. So if you do want to talk about that, do come and chat to me. But that's my boss telling me to do that, by the way. But I'm very happy to chat about any of this. I'm around. very, very happy to be here, and that's my talk.
Super stuff, Reg. Anybody got any questions for Reg?
Yes.
Yes. One moment, you don't get away with that.
Oh, no, I thought we did it at the end.
So tell you that, yes, thank you. Yeah, I'll give you that back.
Thank you. Hello.
Fantastic, thank you for the presentation. Really, really. And nice to be here with everybody. So I'm kind of interested in the multi-cloud strategy. So you talked about AWS, you're obviously leader, the obvious place to start. What is the strategy for your
Multi-cloud, and I'm not speaking for the BBC exclusively, is a very, very difficult conversation to have. In respect to what you need to think about is what are the benefits and values it gives to actually have that additional cloud coverage. AWS actually provide ridiculously good resilience for the scale that I just talked about.
Agreed.
For example. So is there any benefit for us to spend the public funds in another service that provides something that might happen once in a blue moon?
No, I'm not absolutely.
No, I'm just saying.
I totally agree with you. I'm just interested.
So at the moment, what I would say is that the BBC, we do use strategic, where we need it, we have strategies in place to use it in certain environments. So we use Google for certain things, for example, similar data analytics, things like that. But for primarily, we're still AWS at the moment. But you know, we've got all the third-party partners, the CDNs, all of those kind of help us reduce that complexity and have that conversation about multi-cloud. It's a tough one for particularly a public spending company.
No, I totally agree. You spend loads of money making something that you're never going to use.
Yeah.
I totally agree. It just needs some conversation.
Absolutely, we can talk about that later.
Loads of money on something that we use. Yeah, multi-cloud, that's it for you. Any other questions? Yeah, over there. Take the next one.
So it's a bit of a limited knowledge that I got on the subject, but talking about SD and HD streaming, and we mentioned H.264, which is what mostly covered the subject here, I think. When it comes to Ultra HD, as far as I know, it's turning into H.265. And my question was whether the BBC packaging component is more or less the same, and the changes that you had to make to it were they high level, not very
Yes,
low?
very high level. This is not the UHD workflow. So the UHD workflow in the beta worked really well. So those who went and followed the stream, I mean, the tennis was amazing. If you ever saw the Wimbledon tennis in UHD, it looked fantastic. I'm not just saying that because I worked there, but it was brilliant. The Euro final, I didn't watch it on UHD because my neighbours were watching it 30 seconds ahead. So it's slightly different, right? But for those, it's a different workflow. And what we're doing over the next few years is looking at ramping that up. And we know the data is available, and we know 4K TVs are you know, we're testing them every day. They're building up. So.
The next question was, you don't know to answer. H.266. Any plans for that?
Is that AV1?
Not sure.
No, okay. So I don't think 266, but if it's AV1, then perhaps.
Okay, thank you.
576 lines should be enough for everyone, right? There's one question here somewhere. Pass the microphone forward.
Thanks for the just like question about how you overcome the all AWS environments, all resources. How you overcome the complexity of the are you using any framework or any?
Yes. So yeah. Sorry, go ahead.
Any language or
yeah. So all of our hinted at the DevOps and SRE. We use everything as we do infrastructure as code. So all of our code is controlled. All of our infrastructure is controlled through code. It's deployed through services that are pre-scripted. We maintain them as well as part of our engineering, delivering the code that provides the video feeds. We also have those workflows built as well as part of building the infrastructure that the code that itself lands on. So we control all of that. So part of what one boxes there was to help scale that. We provide an initial minimum and maximum values. The system almost decides for us how it will scale to meet demand. Most of this is using things like Lambdas, video showed, EC2s. There are some containers and stuff in there, but we're working towards a lot of changes there as well.
All right, just time for one more question if anyone's got one. Or are we
I've got
good?
one, it's really quick.
It's really quick, I've heard that one before.
So the infrastructure as code, is that using all AWS or using, are you using Terraform or?
We are not using Terraform, so I don't know if anyone from HashiCorp is here. Where's Mark?
I think you got away with that.
Yeah, so yes, we're using mixtures of open source software. I can't remember the name of it, so Boto, something or other, and a few other things that we've kind of melded into our own thing that provides us access to allow to do things like CI/CD into those infrastructures. So it's kind of quite a bit of open source and a little bit of our engineering in there to tweak it, optimize it, and do what we need to do in AWS time.
Thank you again. I think things like Terraform are adept at tools like Boto.
Yes.
I've heard that name in a few years, but I'm glad it's still there and still providing powering the BBC. So Ed, thank you so much. Excellent talk, great questions. Thanks everyone.
All right, okay, so we'll move on to Mr. Hardy in a moment. Just need to resuscitate the laptop. Up going again. So Andrew, you're related to this area now? Yes? Where are the good pubs?
The Globe, on the corner by the station.
The Globe, right, which station?
Moorgate.
By Moorgate, okay, so the Globe by Moorgate, we'll head there after we're done here for a couple of drinks. Jack and Alex are buying a maximum of £1,000 per head. Sorry, no, I shouldn't joke. You might get a free drink out of it. But yeah, we'll go to the Globe near Moorgate Station afterwards. Clicker is here. There we go. All right, so Andrew's going to talk to us about supply chain integrity. Happy?
Yeah.
Which one do you want?
So I'm on my way. Your one.
Okay.
Off we go then. Andrew Hardy, everyone.
Good evening, everyone. Thanks for coming in. So, supply chain integrity is something that keeps most companies awake, not only for the stuff they use internally, but also the stuff that they ship to their customers, because of the issues of liability and so on. SolarWinds attack really put this center stage because it was such a huge hack, and it hacked a company that people relied on to prevent them from hacks. So, amongst other things, but that was the basic premise that we were going on there. So, first, my name's Andrew Hardy. I'm a kind of well-known bad penny on the London DevOps scene. I've been coming to these since the very first one. I've spoken at a few in the past, and it's really good to be able to speak at another one and to welcome you all here in person because I am so fed up with online. I spend my life in Teams meetings and so on and so on and so on, and I have had enough. Okay, so we've had a little reorganisation, actually not so little reorganisation in R3 in the past couple of months, and I now am leading a team that's doing infrastructure services and basically platform engineering as well. And the idea of that is to provide consumable and composable services for our internal customers. In other words, the teams who are developing the core products, that is what we sell and earn our cash with. I'm also chairman of the British Community Society DevSecOps Expert Group, which has been looking at some of this. I'm afraid the group has suffered very badly with the pandemic and some things going on at PCS, but there it is. Now, here's the threat landscape. Like the weeds, the threats are everywhere, and new ones keep popping up all the time. So, what to think, what to do, how to sleep at night, and so on. Okay, so the ground rules. Trust nothing, trust nobody, check everything, check everyone, Assume nothing. Ah, done. I can go home now. But seriously, Corda, I need to say a little bit more about R3 and Corda. So Corda is a permission blockchain network. So it's a network that customers join, but some of those customers, some of those customers wish to run our software themselves in their own infrastructure, their cloud, their tin, whatever. We're also moving from a single network model to a network of network models, where we're going to have more customers that are wanting to have control over their own components of the Corda network. We're changing a lot of things in the way Corda operates to make it into a more scalable service, because we're getting very good uptake of what we're doing. We're moving into new areas as well, which are very demanding, and customers with very demanding requirements, reliability, security, assurance, blah, blah, blah. You may have heard of things like SOC 2, which is like PCI DSS with knobs on. And those customers expect a very high level of assurance and reliability with regard to the quality of the software that we deliver. Now, scope. This is a huge subject, so I'm limiting my scope so we can actually all leave at a sensible time. So everything from code commit to running production deployments, but no further. So all the code and the tools that are used to do that, your SDLC, your DevOps pipeline, everything from code commit to stuff lit up in production environments. And all the code components you import from external sources. This is the problem. You import a lot of stuff these days in order to deliver functionality to yourselves and your customers. No further here. Out of scope is direct attack on running instances. That's out of scope for this, but it's still a hell of a lot. Okay, so where to start? Back to this lovely meadow. This is a meadow I actually visited in the photograph. This is not off Shutterstock. This is a meadow I know. Which plants do you not recognize? Well, which ones? Where? Which ones do you not want? Or which are the ones you do want? A weed is only a plant in the wrong place, as the gardeners say. Well, you could say that about the stuff you've got running in your systems. So, this is a rather handy threat matrix that I picked up on GitHub, which shows you some. I'm not going to go through it because you can read it when you download the presentation afterwards, should you wish to do so, of course. So you have all the way through showing you where the threats exist across your whole development and deployment landscape. So it's a very handy reference point and does remind you of how little trust you must put in things. The SolarWinds hack was a very interesting one because it exploited an assumption that a file created locally and then reused later would be safe. It wasn't. That's how they did it. A temporary file was created during the build process, which they monitored, modified, and then it got rebuilt back into the packaging of the final product. That's how they did it. So that's trust nothing. So begin at the beginning. Your source code repo, your crown jewels, right? Because that's your code. Now we're using the code not just to write applications, but to do all the infrastructure as code to deploy it. There's a big change in the way trust applies. And this is something I've had great difficulty convincing conventional managers. Fortunately, none are present tonight. And besides, the managers here are all very good, but this is in previous companies. Trust shifts from who has access, root access to running VMs, to who has access to the code that will run as root. That's your infrastructure code, because to do anything, it has to run as root. So you have to guard access to that absolutely as tightly as a root password to a production system, because it's going to go all the way through to production systems. It's going to create them, and it's going to configure them, and it's going to deploy into them. Are you controlling that right access? All your automation stuff is going to need read access to this because that's what it's there for. But you've got to control the right access really tightly. And what about proving that the people who are modifying the code are who you hope they are and who you think they are, and proving who they are So you've got hardware tokens, signed commits, tags, merges, because you can sign all of those, not just commits, and protected branches to ensure the rules are enforced. Not nearly enough people use protected branches. And trusted timestamping, this is one that always gets forgotten. If you can't be sure the timestamps on your code modifications are accurate, you can be subverted because you can rewrite history. It's the same as event logs. Okay, so you've got a code commit and a merge, now what? Right, third-party component problem and the local trust problem, so instinct. Third-party components, we're importing stuff all over the place, library for this, library of that. The last estimate I saw was most application software now is only 15% original code, and it's getting less. Basically, all you're doing these days is writing business logic on top of imported functionality via libraries. Yeah? So you are relying more and more on the stuff that you are importing and less on your own code. And the more rich functionality your imported component provides, of course, the bigger the attack surface. The build process incorporates those to make your artifact, what you deliver to your customers or run internally. And it's very hard or impossible to determine the safety of those imported components a priori, by examining them, I mean. Mostly you rely on CVE reports of discovered exploits. So you've got security in the build components. Now what? Well, the tools, the build process is run. The bit of your SDLC pipeline you have to trust is the builder. It's like you have to trust your file system. There's no alternative. You have to trust your builder. So you've got to make sure that what goes into the builder is safe. Can you be sure the builder hasn't been compromised? You're using a package, program, whatever, and you run checksums to make sure the binary has not been compromised or tweaked in any way. And do you use source code protection principles for the pipeline code that runs in the SDLC pipeline? So we're not talking about the infrastructure as code here or the application code. We're talking about the code for the pipeline that does the build. If you're making a binary or a library, that's about as far as you can go. But if you're turning out a Docker container, you have lots more fun because you're importing stuff from outside. You import a container that's got multiple layers. What's in those layers? Where did they come from? Can you check them for CVEs? One trick I've seen that's used in the States, the US Defense Department runs a huge container registry called Platform One. Which is actually based on Harbor, by the way, not on Nexus or Artifactory. And what they do there is they re-layer the containers that are being published for use in the Defense Department. So you strip out whatever the base layer in the container is, your from statement in your Kubernetes manifest, and replace it with one they know is good. So that's the equivalent of taking an application and running it on a VM that you've created yourself for a known good configuration. That's a cunning trick because container files are basically just glorified tar archives. You can take them apart, play with them, and put them back together. Layer substitution, because your container consists of multiple layers, a base layer, a bit on top of that, a bit on top of that, a bit on top of that, and then your functionality on the top of it. So now you've got some artifacts you're confident about. Now what's your next problem? Well, your artifact repository is also another crown jewel, but it's a crown jewel of a different kind because it's made stuff. Now, if you follow the CI/CD principles and you've read, the book by the Jez and Dave Roadshow, Jez Humble and Dave Farley about continuous deployment, you know that your artifact repository should contain only tested artifacts that can be deployed at any time, continuous deployment. But you don't want them only tested, you want them assured as well. So you want to make sure that your process that builds and delivers those artifacts to your artifact repository has checked them for CVEs and so on, and various other checks and tests that you may build into your pipeline code or your tests. But CVEs are based on reports, stuff that's discovered that can change over time. Something that's green today could be red tomorrow. You have to keep on checking. So what do? Keep checking them or keep rebuilding them with the checks? It depends what you're doing, but the principle is keep checking. Now you have to deploy them. So same principle for the artifact build process about the deployment code and so on. You've got to protect that code very, very highly, especially because the deployment code is usually going to contain things like access tokens or, heaven forbid, passwords. Now you've got the environments to worry about. You're going to have several environments, you know, at minimum, dev, staging, production, whatever. And none of those should be done by humans. That should all be done by automated processes. So you're back to authenticating those processes and authorizing them to make the changes to your higher level pre-production and production environments. So now you've got your code running in an environment. Now what? Well, you want to promote it towards production. It's your pipeline, or as it's sometimes called, your route to live. In other words, how to get from a dev environment up the line to increasingly secure, monitored, logged, and protected production environments. How will you police environment promotion? If you live in a regulated industry like we do in fintech, and you have SOC 2 and the question of responsibilities, accountabilities, and separation of duties, probably, unfortunately, that has to contain a manual step. The manual step being somebody signs in blood that they authorize this release, and that has to be recorded for the day when the lawyers and the auditors and the vice squad come round. Yeah? Now, GitOps, I'm sure you all know about GitOps, is basically how the only difference between automated created environments is basically metadata. Its size, its number, its access control lists, and so on. So GitOps represents the difference between your dev environment and your staging environment simply as a pull request that changes the metadata describing the environment. And GitOps works on the principle of when you do a merge of that change to the metadata that define the dev environment, it automatically triggers a build of the next environment, staging, and deploys the code into it. Note, this is not the same as the old model, where you update the code in the running environment or VMs. You make new ones. You make from clean every time. So you've got it to production as carefully as you can. Now what? Remember, things can change. You've got stuff running in your production environments, but you can suddenly get a CVE about one of the components that you have used to build or deploy with those applications. So you can rescan, keep rescanning, but if a CVE shows up, now what do? Where is the code that incorporated that component running? And what of your services will be impacted by that vulnerability being in use? Similar, the imported stuff. If a third-party author, whether that's a company or an individual, because a lot of the open source stuff is sometimes just one bloke, you know, Redis being the prime example of one bloke in the basement turning something out. What do? If their repo has been compromised, which has happened in several exploits, where the repo, where companies or open source organizations will put their components or download has been compromised, you need to know where you are using that, which environments it's running in. Is it only got as far as dev? Okay, sweat, relief. It's got as far as production? Shit hits fan. Yeah. And what about your developers, including your own staff? Supposing somebody in your organization, one of your developers, is discovered to be tainted or suspect in some way, where is his code running? And if you've deployed potentially tainted code to a client, now what? As I said, we have customers who want to take our Corda permission blockchain network code and run it on their own infrastructure, whatever. So we are not only a service provider, but we are also a product provider. So we have to be doubly careful. So observability could be your friend. Now, we all know the arguments about observability versus logging versus metrics versus tracing. I won't go into that today, Just suffice to say, think of observability of as much as you can possibly capture, and we'll leave it at that. So what you need is something that can maintain an audit trail of authors, third-party components, third-party suppliers, intermediate repos. You talk about CDNs. CDNs can get compromised too, and have been. And again, things you trust as a way of giving you, whether it's speed or reliability, or that can be compromised. And right the way through to your build and deploy pump. I don't know a tool that does this. Any of you know one? Come see me, because I don't know a tool. Now, Nexus claims to do something along these lines, but it's actually cheating, because it requires you to tag everything, and all they do is a tag search. Well, hey, I can do that. Okay? Carefully crafted log entries are probably going to be your friend with rich tagging. People don't use tagging enough. People think tagging is just a way of identifying things. It's not. It can be used a hell of a lot more than that, much richer. And if you're going to automate it, why would you care for 50 lines of tags instead of one? It doesn't matter. Okay, and your next headache, your clients. As I said, we ship stuff to customers. So you sell them stuff, they want to be confident. It's also in their agreement, and the lawyers will come around. So what to do about the upstream long tail all the way back to the origins? What's going on to address all this? So let's have a see what's going on out in the world about this. And I think one of the things that impresses me the most is how much of the security and integrity software that's out there is open source and not proprietary. And people are preferring that because it is open. So Active, did you know April was National Supply Chain Integrity Month? Just not here. It was in the States. They had a big push over there, because you remember Biden put out this thing that was also about zero trust networking, zero trust access, all that, which is another great, very interesting area, by the way. The FBI warned about supply chain attacks way back in February 2020. So we have CISA, the US Cybersecurity Agency, Department of Homeland Security, DoD Center. I'm very confusingly, America has an NCSC, the same as we do, but it's just different, and there's no connection between them. And our NCSC, they've ever so slightly cheated. They have switched from giving you advice on what to do to telling you the principles you should follow. Now, this may be simply pragmatic, because keeping advice on what to do up to date is hard and a lot of work, and of course leaves you open to blame game. So applying the principles, which after all is what things like SOC 2 and PCI DSS do, they don't tell you what to do, they tell you the things you should be doing, or the goals you should be achieving in security. So it's probably a sensible move. What about government and industry initiatives? Well, you've got all these departments in the States that are very active and pumping out a hell of a lot of stuff. So these are some of the open source community initiatives I'd like to draw your attention to. I'm merely signposting these. A lot of these are fairly early in their life cycle. But what they are doing is addressing that important question of attestation down the chain, either the chain from components you import into your builder, or the chain from the artifacts you deliver from your builder and then ship to customers. This is SIGSTOR, which is a standard for signing, verifying, protecting software. So this is a bit similar to attestations, blockchain, that kind of stuff. Right? I won't go into the details, it doesn't matter. But there's an RFC for doing tamper-resistant timestamps. Back to the question of timestamps. If you don't have accurate and immutable timestamps and logs, you can be subverted and you won't be able to tell, because history has been rewritten. In Toto, it's a very interesting one. Most people have never heard of it, but if you actually look at it, it's a really interesting framework. And they're doing a collaboration with all those people and those big US TLAs and four-letter agencies about doing this. So it's based around metadata that you can use in the attestation process. I'm not going to go into it, it's really complicated and we haven't got time. Plus, I don't understand it fully. And then there's TOUGH, the update framework. What this one is particularly interesting about is this is the one about getting that last mile, getting that software delivered to your clients, but it even deals with compromise of repository or signing keys. That's a bit of deep magic that I wish I understood, but it's a wonderful thing to have because those kind of keys for attestation, verification, access, validation are one of the first things that threat actors go for. And in Toto and Tough can work together. Right, so now we have Google, the Google Salsa, SLSA, supply chain levels for software artifacts. This is new, it only came out in June, but the fact that it's Google probably means it's going to get some good traction and attention. What I suspect, so it also works with InToto, which is why I think InToto is going to succeed. So this with InToto backed by Google could do well. Probably will do well because the public perception, I mean industry perception of this is now so high that they will be grabbing at any solution that looks like it's credible and deliverable. Okay, now where to look for information? This is absolutely the best resource that's out there. This is the CNCF. It's about 24 pages, 45 pages. I printed it double-sided, that's what. And it's excellent advice, identification. You must read it. It's your #1 source material if you're interested in this problem space. This one is the UK one. It's back to their principles. They propose a series of 12 principles that you should employ or think of or try to implement when doing your supply chain integrity. And then this one is what you give to management. There are none here, which is a 2-page management summary, which is a nice kind of diagram with little arrows and flows and pretty colors, but as a way of summarizing it to people who are not deep tech like you guys. It's an excellent resource. Okay, this is the CNCF technology radar. I have to say, from a shaky start, I have become seriously impressed by the work of CNCF. They are hosting now, sponsoring, adopting, and promoting some extremely good tools, not just in the security sphere, but all across things that we all do. So what this is just a snapshot in time. This is not predictions about tools that are going to succeed. This is just a snapshot of what people are using now. And most of the names here you're familiar with. So this is the stuff that's popular and being used in action to address this issue. Now, there's some names here you know. There's also some names you know that are not here, which is interesting. I shall name no names, but you can figure it out yourself. So, are we there yet now? No, we're not. It's getting close. But you have to remember, this is a journey, not a destination. There is no end point. It's constantly changing. The threats, the actors, constantly changing. And if you're delivering software to customers, you've got to project your assurance outside your own boundaries. It's like, you know, putting armor on the car you drive out of your front gate. It's what you're doing, really. And there's this is all stuff you've got to consider on top of all your normal IT department and security people going, no, you can't do that. This is all on top of that. Yeah. So this stuff is complicated. My head hurts. I'd like to lie down in this nice warm meadow. This meadow I know, I have actually lied down in it in very warm weather, which is not in this country. But I might manage a few simple questions. Thank you.
Hardy, that meadow looks just awesome. Is it just around the corner on London Wall, right? It's not, is it?
Well, the meadow.
I'm joking.
No, the meadow is many hundreds of miles away.
Hundreds of miles away in the world, are far away from here. So, has anybody got any questions for Andrew?
It's that troublemaker over there.
There's a troublemaker here as well. Which troublemaker do we go to first? I think I'll give it to Mr. Markham because he's closest to me.
Thanks, Matt. I was going to say the last point about the normal IT security stuff. I mean, one of the things I've observed in recent years is that some of the IT security ivory tower type mentality isn't very helpful to helping us.
Is unhelpful?
Yes, it's
Well,
unhelpful.
I'm glad you said that. I didn't have to say that.
To this end-to-end security mindset that you need to adopt in order to really embrace.
The difficulty I have, and I guess difficulty with many of us have with our security departments is their favourite word is no, not how to fix this. Yes, because no is the easiest, safest. I think you had another point to make.
I was really just saying it's got to be about the end-to-end security and actually trying to have that holistic conversation and actually risk assess it like a bunch of adults and not feel like when you go to the security team, you're a kid asking for money or a kid asking to do something, right? And that's that kind of, I find that kind of cultural dynamic is quite now.
You know,
That was my point, really.
My view is we shouldn't go to the security team after we've done something and go give us marks out of 10. How did we do? Security. My mantra about this is security is not a moat, a drawbridge, or a wall. It's a design pattern, and the security department team should be involved from day one, not run up and down the country and go, "You've done that all wrong." It's not helpful. Yes, and troublemaker over there.
Troublemaker number 2, please.
No, he's auditioning to take my role in the London DevOps.
Fair enough. So it's a general question about the supply chain attacks. So we discussed all the software bit, but mine is a more generic question about the hardware part. You might have heard of the story that ran in Bloomberg, I think, a year or two ago. Super microservers that were supplied to many, many big companies in the world, including Apple and others, that were actually allegedly, according to that story, included a chip that allowed external connection directly to the hardware and all that sort of stuff.
Well, if you start getting to the level of paranoia, you're worried about your
Not the
hardware.
parallel, what principles could be transferred or what new principles could be applied?
Well, of course, I could reference another R3 product, which is called Conclave. Who did that? Throw him out.
Product.
Coffee for anyone?
I could reference another R3 product, which is called Conclave, which is how to do secure computing within the SGX enclave in Intel processors. And that is now one of our major products. As part of the great reorganization a couple of months ago, R3 has been reorganized around 2 products, Corda, what I've been discussing tonight, and Conclave, which is secure computing, where you run it in this Intel SGX enclave, and you are guaranteed security, even if the entire underlying computer is compromised, allegedly.
Excellent, thank you. Any other questions for Andrew?
Oh, that's a relief.
Does anyone want coffee? This guy is now making one for everyone who wants one.
Guys, please help yourself to more wine and beer and pizzas left. I got into trouble with the lovely son Al, who's been organising all this, because when I saw the number of pizzas that arrived, give me the right, it's not enough. There'll be loads of people. Well, so probably that was too few, and now it's too many. So please eat as much as you can, because otherwise I apparently have to carry all the boxes home. Thank you so much for coming. Great to see you all.
So, yeah, you've probably seen me fiddling around here with this laptop. It's live streaming. We've actually managed to get the live streaming working pretty well tonight. Thanks very much, Sonal, for the Wi-Fi, the guest Wi-Fi, which is working well. We've got almost as many people on the live stream watching from places as far afield as Wales. Oh, and India. So yeah, almost as many people on the live stream as there are here. So we'll carry on doing that. So thank you for everyone in my laptop for watching. Got a few familiar faces there, actually, people like Sean Ferrigan, I'm sure many of you know, watching the live stream, Babatundi, Pete Turner, James Murphy, those sort of people, thank you for coming. So yeah, I'm delighted everyone is here. If you're on the live stream, not comfortable coming to a real meetup, then we're very happy to have you via that medium as well. That's always going to be there as much as we possibly can do that. So yeah, that's about it from us for tonight. Thanks to everyone who's come from wherever you come from, whether you've kind of done this kind of weird evening commute like I did from my bedroom, or if you've been working around in London somewhere. Want to just shout out just for the last time. Thank you so much to our speakers, to Edge and Andrew. Brilliant job. Thank you. Massive thanks to Sonal and her team for organising yes. The hard and change his mind all the time, but you've got to be agile about these things, right? Money loads and money not too many. Theory of constraints, right? Gold round, DevOps, yeah. I'll get the code. So yeah, last thing is just to say thanks to everyone on the live stream for coming and sitting at your computers and watching us. Brilliant. Thanks to all you for coming. If you're interested in speaking, hosting, sponsoring, anything like that, come and find one of us. I think Jack's got to shoot off, but Alex and me will be going to the, I'll be going to the pub. You coming, Alex? Yeah, cool. So, so as soon as we get Chat out of here. So now, when do you want us out of here? By 8:30, which is in, so we've got 16 minutes to drink as much as possible. Whilst not violating the code of conduct, including fighting people. And eating the pizza, yes. Get Hardy out of trouble by eating the pizza, please. Yeah, that's it. So, we're not going to do a meet-up next month, so, and also I went to see Christmas Carol last night at the Old Vic, so I'm already feeling Christmassy, so happy Christmas, everybody. We'll see you in the new year. We'll do another meet-up, don't know where, don't know when. I know a song about that, but yeah, we'll let you know what that's going to be, where it's going to be, who's going to be speaking. Yeah, that's it. See you at the pub. Thanks all for coming. Bye.